Welcome to the BWSpec 4.10 probe setup and experiment setup for Raman. In this video, we'll talk about what relative intensity correction is and then go over creating a probe profile and hardware setup using the factory relative intensity correction ratio file. Lastly, we'll demonstrate creating an experiment and experiment setup using the probe profile. Relative intensity correction is specific for Raman applications and is a spectral response shape correction based on a NIST standard reference material. This eliminates spectral response differences between instruments, thus minimizing variability when comparing data on different instruments with the same or different laser excitation wavelengths. It is recommended to use relative intensity correction when using the instrument for quantitative measurements or chemometrics. We provide the user with a relative intensity correction ratio file upon purchase of the instrument. This ratio file is specific to the probe and instrument, so if you use different probes with the same instrument, you will need to have a relative intensity correction ratio specific to each probe. This is where probe setup comes into play, making it easy for the user to pair probes to ratio files. To create a probe profile, click Setup, Hardware Setup, then click on the Probe Setup tab. Click the New button, and Probe Setup will appear. Enter a unique name for the probe. We recommend the following naming convention: probe, C code, probe serial number. By default, the C code will be there from your unit already, and you just need to type in your serial number. For this example, we're going to use probe, C code OUJ, and the following serial number. This allows for a simple way to pair probes to instruments and is especially helpful when dealing with multiple probes or instruments. Click the radio button, select Ratio at Hard Drive, and then click the ellipses button. Locate the ratio 3 C code of the unit .txt file provided to you on the B&W Tek flash drive. For our example, ratio 3 underscore OUJ underscore L.txt. The ratio 3 information will now be displayed. Experiment setup allows users to create and save a set of parameters to define what and how to measure. This includes acquisition, spectral processing, analytics, and timeline. We will go over each of the sections and create an experiment using our new probe profile. To begin, navigate to Setup, Experiment Setup. The Acquisition section defines the settings used in each acquisition, including integration time and number of averages. For Raman experiments, this also includes the probe used and laser power setting. It allows for easy selection of the probe profile from the list of those that have been pre-configured in probe setup. First, select the newly created probe profile. Select an integration time and unit suitable for your sample measurement. You can determine optimal integration times by collecting data in the main window that gives the best spectrum for your sample, where the peaks of interest are about 50,000 counts. Select an average number. 1 is typical, but more may be needed if you have a longer integration time or if you want to decrease noise by averaging. Select a laser power percentage to use. 100% is good for white or light colored samples. For colored samples, we recommend setting the power to 60%. For dark colored samples, 10 to 20% or lower is recommended. If you burn the sample, use a lower laser power with a longer integration time. The spectral processing section is to perform predefined processing to data as it is collected. We are focusing on operations in the Raman workspace, which is limited to relative intensity correction and additional processing. Please note that relative intensity correction cannot be done unless dark subtract is done first. Additional processing allows for multiple post-processing steps to be applied after the intensity correction, including baseline removal, smoothing, and derivative. Check the box next to Enable Relative Intensity Correction. Check the box next to Additional Processing, and then click the button to open the Post-Processing Setup window. Click New to add a data process. In this example, we will do smoothing. Type in a name. For type, select Smooth in the drop-down menu, and under Smoothing Type, we select Savitsky-Golay Smoothing with a window size of 2. Click the Done button to add this to data processing. Additional processing steps can be added by clicking New. Click Close to exit the window. The Analytics menu provides spectral analysis functions to be performed on the processed data, with the results displayed in the Analytics tab. The peak monitor allows the user to perform peak analysis on defined peaks, as well as arithmetic on the analysis results. Basic measurements define the peak's property values. Derived measurements define the measurement values that are derived from the basic measurements. Check the box next to Peak Monitor, and then click the button to open the Peak Monitor Setup window. Select Basic Measurements or Derived Measurements to define these. Click New to add a basic measurement. In our example, we are going to measure the acetaminophen peak height above the baseline at 1324 Raman shift. In name, we type peak 1324. In type, we select height, and under select position, we select Raman shift with a start and end of 1314 and 1334 respectively. Then click the Done button to add this to the basic measurements. Click Close to exit the window. Derived measurements can be added and are derived from your basic measurements. From the drop-down menu, choose an operation. There is a variety to choose from, including a ratio of 2 peak heights. We have one basic measurement and will add a constant to give us our derived measurement. We're going to name this peak ratio and select the operation A over B. Measurement A will be the basic measurement, peak 1324 that we defined earlier. And measurement B is just going to be a constant value. Normally, if you're going to do an actual peak ratio, measurement B will be a different peak, and you would find the ratio between the two peaks. The timeline function provides automated, timed recording of an acquired spectra as defined by the user. These spectra are saved as individual files and displayed in the main graph. If dark and reference spectra are taken before initiating timeline acquisition, they will be added to all additional timeline-created spectra. Check the box next to Timeline, and then click the button to open the Timeline Setup window. Check the box Display Spectrum Overlay to have all the timeline acquisitions display in the main graph. Click the Ellipses button to select a save location for the new data. Select the delay time between spectra in milliseconds. In this example, we'll use 1000. Set the total number of spectra to collect. In this example, 12. Click Set to accept the timeline settings. We must save the current experiment before we can use it. Click the Save Config button, choose your file name, and save it. You can now close the experiment setup window. The main graph will adjust and display a dual chart for timeline with an Analytics tab. A timeline acquisition button will appear in the toolbar. Collect a dark scan, then click the Timeline Acquisition button to begin collecting data. The top graph will display each spectrum as an overlay. The bottom graph will display the peak monitoring, peak height in this case, as a function of time. To toggle different measurements, go to the Peak Monitor panel at the bottom right and select the peak from the drop-down menu to activate the measurement. At the top of the main graph, the Analytics tab will record the defined measurements for each scan. To go back to the default workspace display, deselect everything from the experiment setup and then save it as a new default configuration file. If you need assistance locating the Ratio 3 file for your instrument, you may request a copy at bwtek.com/support. Please refer to the BWSpec 4.10 user manual, as well as other support videos for further assistance. Thank you for watching.